everybody, my name is Vincent Yao and I am 11 years old. I will be introducing my project for the Green Microbead Challenge, a solar-powered carbon footprint monitoring system. My project is related to 3 UN SDGs, Goal 13, Climate Action, Goal 12, Responsible Consumption and Production, and Goal 7, Affordable and Clean Energy. My project is mainly on Goal 13, Climate Action. According to UN's report, the increase of carbon emissions caused a lot of climate problems. So, I decided to make the carbon footprint monitoring system to monitor carbon emissions. The microbead can gather data from various sensors and then send the data to the cloud. The data will help us monitor carbon emissions, and the government can use the data to control carbon emissions. Since the microbead do not support Wi-Fi but it does support Bluetooth, we have to use the phone as a proxy between the microbead and the cloud. Besides the sensors, we also need a power supply to power the microbead. To align with Goal 7, we will choose affordable and clean energy. Many different types of energy have been considered, but most are not suitable to be used in Singapore since the wind speed here is too slow and there is also no fast-flowing river. Solar energy is therefore the most viable, especially with a tropical summer or year weather. It is clean as it has no carbon emissions and it is also affordable. So, we will use a solar panel as the power source for our project. We also need to store energy generated by the solar panel so that the monitoring system can still function at night without sunlight. The main drawbacks of the traditional power storages are that they are not eco-friendly since they have high toxicity and will produce pollution, so they cannot be disposed anyhow. That leaves us with the supercapacitor. It is not a battery but a container for electricity. There is no chemical reactions when charging and discharging, so it's eco-friendly with low toxicity, is disposable and has longer cycle life. To save energy further, the system will turn on the sensors only when it is monitoring, then the microbead will go into power save mode when it is not, to consume less power. With this setup, the system will consume power only when it is necessary and go into deep sleep mode when it is not. This is aligned with Goal 12, Responsible Consumption and Production. Finally, our project is aligned with all the 3 selected SDGs. These are the components being used in my project. My project consists of a solar panel to power the microbead and store the energy inside a supercapacitor. The energy will be used by the microbead to read the temperature, humidity, and carbon dioxide using the sensors, and the microbead will send the data to the devices. Let me show you the components. This is the microbead. I chose to use the V2 microbead because it supports deep sleep function and support Bluetooth function better. These are the sensors. This is the carbon dioxide sensor, and this is the sensor for temperature and humidity. This is the I/O extension board I will use to connect the microbead and the sensors. This is the supercapacitors to store energy, and this is the solar panel I will be using. After assembly, all the components will look like this. I used my Lego pieces to fix all the parts together. This is what it will look like after I put on the solar panel. I have to put it outside and face the solar panel towards sunlight so it will receive the most solar energy. Behind the solar panel, everything is working together. Now I will show you the source code for my project. On start, the microbead will set the interval to 300,000. Interval is basically how frequent the microbead reads the data. By default, it is 300,000 milliseconds, which is 5 minutes. It will also set paired to 0. It means that the microbead is not yet paired to any device. Then it will start Bluetooth UART service. When it is connected, it will set paired to 1. In the main loop, the microbead will read the data every 5 minutes. It will reset init and read the SGP30 sensor. When the sensor is first initialized, it needs about 15 seconds to warm up. So its default carbon dioxide value is 400, which is not accurate. So the microbit will keep on reading for a new value until it changes from 400 to something else. That means that the sensor is ready. Now it will read the temperature and humidity from the AHT20 sensor. And the voltage sampling of the solar panel is connected to P1 of the microbit, and the voltage sampling of the supercapacitor is connected to P2 of the microbit. So I will use the analog read function to read the voltage and send to the variables. Now I have already gathered all the data. I can use the Bluetooth UART write to send out all the data. At the end, it will write line done to tell the proxy to forward the data to the cloud. Now, only when the microbit is charging, it will still set interval to 5 minutes, which means it will read data still every 5 minutes, but when it is not, it will be every 30 minutes in order to save energy. Now it can request low power if it is paired, because it can no longer pair when it is in low power mode, so it have to ensure that it is actually paired. For the SGP30 sensor functions, since there is no existing library for this sensor, I made 3 functions myself following the datasheet to send the corresponding commands to the sensor using the I2C write function. The reason I use the power save mode is to align with the SDG 12, so the microbit will only consume power when it is necessary. When it is in full power mode, the power consumption is about 50 milliamp, but once it enters low power mode, it will only consume less than 3 milliamp. This is the proxy I will be using to send data collected by the microbit to the cloud. I have to authorize it to access my Google account first. Continue. Now it's authorized and I have to connect it to the microbit. Okay, it is paired. So right now it will list the data collected by the microbit down here in this area, and the values, the data, will be saved automatically in the Google Sheets. So I have authorized and connected it. This is the data I collected just now. So but it's very long. It will only read the data every 5 minutes, and the video is 1 hour, so I will fast forward it. So I use the Google Sheet chart function to display the data better. And at first I put the carbon dioxide temperature and humidity together, but in one chart, but I realized that it's a bad idea because the carbon dioxide is very high and you can't really see the change in temperature and humidity. So I separated them into 2 charts, and now we can see the temperature and humidity better. It has been a rainy day, so the humidity is quite high, and the carbon dioxide actually increased because maybe it was cooking time and people were cooking, so more carbon dioxide were released. Now and the Google Sheet also support other charts like bar chart, pie chart, so you can choose any chart to display the data collected by the microbit. That is all for my presentation. Thank you for watching, and Hope you like my project.